Let's move on to Game 7 from Class Handout 2 on signaling games. As before, we're going to look for initially all of the dominant strategies. So player 1, if you're here, up will give you 1, down will give you 0. Again, pretty obvious, up is a dominant strategy. Put a D right there. If you're right, up could give you 2 or 0, down will give you 1 guaranteed. We can't be sure. Righty does not have a dominant strategy. What about player 2? If up is played, if you knew you were here, X would beat Y. If you knew you were here, Y would beat X. No dominant strategy there. In player 2, if you knew you were here, Y beats X. And if you knew you were here, Y also beats X. So this game has 2 dominant strategies. Well, let's see if we now have enough information, to solve for anything else. Have we figured out what should happen here? Well, this is kind of like the last game where learning what player 2 does if down is played really does not help righty because he's going to get 1 either way. And what about player 2 up here? Well, he would say to himself, I'm either in an equilibrium in which just righty goes up, in which point I want X, or I'm in equilibrium in which righty and lefty go up, and given the probabilities, I'm going to, want Y. So no, we can't get anywhere else. The other tool of knowing that the only person who might go down is righty, that doesn't help because that helps figuring out what player 2 should do down here. But like the last game, we already know that. So we now have to go to let's basically consider something. Let's consider, could there be an equilibrium in which righty goes up? Remember, the square means I am not sure that righty is going to go up. Circle means it's going to happen, has to happen. Square, and later triangle, mean it might happen. I'm just considering it. All right. In an equilibrium in which righty goes up, what does player 2 do if up is played? Well, if up is played, he's going to say to himself, if I have a 50% chance of being here and a 50% chance of being here in this equilibrium. So, if I play X, I get 1/2 the time, and I get 1/2 the time and 0/2 the time. And if I play Y, I get 0/2 the time and 4/2 the time. So you'd much rather play Y. So in an equilibrium in which righty plays up, if up is played, player 2 will go with Y. Is this an equilibrium? Remember, I haven't proved that righty wants to play up. I've just said, let's consider it. Well, in an equilibrium, see if anyone regrets. Does righty regret going up, given player 2's strategy of Y up here and also Y down here? Let's see. In this equilibrium, you're getting 0. But had you done something else, given player 2's strategy, you could have gotten 1. This is not an equilibrium, right? Because righty would say to himself, all right, given player 2's strategy of if up Y and if down Y, my strategy, that I'm supposed to do up, gives me 0. If I did the other thing I could do if I'm a righty, I would do more than 0. I would get 1. So this is not an equilibrium. So what I've shown is, first, if there is an equilibrium in which righty goes up, it has to be that player 2 would respond to up with Y. But in this equilibrium, player 1 regrets. So this is not an equilibrium. Hence, there is no equilibrium in which righty goes up. Well, righty doesn't go up. He's got to go down. Let's put a triangle around down. Again, triangle represents. Let's see, could this be? In this equilibrium, now we just have to figure out what player 2 would do if up is played. Well, in this equilibrium, right, it's separating equilibrium. Player 2 knows in this equilibrium that he's here. And of course, if he knows he's here, he wants to go with X. But we got to circle both X's because that's what he's doing. He's saying if I'm in this oval, I'm going with X. Now let's see, does anyone regret? Well, player 1, if he's a righty in this triangle equilibrium, he goes down, he's getting 1. He expects to get 1 in equilibria. But given player 2's strategy, had he gone up, he would have gotten 2. He regrets. There is no triangle equilibrium either. So what this shows is, first, if there's an equilibrium in which player 1 plays down if he's a righty, it must mean that player 2, if up is played, would go with X. But this is not an equilibrium. So there's no equilibrium in which player 1, if he's a righty, goes up. There's no equilibrium in which player 1, if he's a righty, goes down. Hence, there is no equilibria in this game. This game has 0 equilibria. Well, what actually is happening is I kind of told you like almost every game has a Nash equilibria, which is basically no regret equilibria. This game does have an equilibria if you allow for mixed strategies. I'm not going to go there. So this game, I'm not proving this. This game definitely has a mixed strategy, no regrets equilibria, but these games are hard enough, so we're not going to worry about that for this class of games. So effectively, for these class of games, we're only going to consider pure strategy equilibria, and there are not any in this game given these numbers. Thank you.